Hello, my name's Luca. I'm one of the site managers for Pact's Leederville office development for the ABN Group.
So there's multiple steps in the installation of post-tension suspender slabs. First step is the installation of the anchor head, followed by the feeding of the anti-burst spirals, then the grouting duct, the strands, the creation of the dead ends, and the closing up of the anti-burst spirals. There's multiple benefits in designing post-tension slabs. Some of them being we can design thinner slabs with less rebar. We can increase our spans from column to column, allowing architects and designers to design more flexible, larger spaces. We also have a higher durability in the concrete. Due to the compressive nature of post-tension, we reduce that shrinkage crack, which limits the amount of water ingress, potentially affecting rebar durability.
Today we're in the final stressing phase. This involves stressing our 12.7mm cables to 85% of their breaking strength as detailed by our structural engineer. In this case, it's 156.4 kilonewtons or 15.6 tonnes of force per cable. During this process, we install our stressing jack onto the cable. The jack essentially clamps onto the cable, stretches the cable, and we monitor the loads on a calibrated meter connected to the jack. Once we achieve these required loadings, the jack releases the cable and the wedge pins clamp the cable against the PT live end, essentially locking the cable into place. Once this is complete, we take measurements of the cable extensions. This is reviewed by our design engineer. Once they've made comment and they are happy with the extensions, they approve the cut and seal process.
So today we're in the final phase of the PT installation. This involves the grouting of the PT tendon ducts. This is an extremely important process due to two following reasons. The first being even load transfer. Once that PT duct is grout filled in concrete and we deprop our slab, we have an even load transfer through the slab and the cables as the deck begins to deflect. The second reason is due to durability. When we encase our PT ducts in concrete, we essentially are protecting that cable from any form of corrosion. If we never encase that cable in concrete, there's a potential for future water ingress, which potentially could corrode that cable and then in future cause structural failure.